Good morning world. I'm Godiswara Subudayar, majoring in physics, year 2. My ID number jp10554/18. Today I'm going to give presentation for subject jif213 waves and vibration. The topic I would like to share about pyranometer usage in solar radiation and energy generation of photovoltaic cell. This video is for educational purpose only. Pyranometer. A pyranometer is a tool used to measure solar irradiance on the surface of the earth. In simple terms of pyranometer measures the amount of sunlight reaching the earth's horizontal plane. The pyranometer was invented by a Swedish meteorologist and physicist named Anders Knudsen Elström in 1893. His pyranometer was the first device invented that was able to measure both indirect and direct solar radiation. The main types of pyranometers are thermopile pyranometers, photodiode-based pyranometers, and photovoltaic pyranometers. These three types of pyranometers are classified into either thermopile technology or silicon semiconductor technology. The spectral response, which is light sensitivity of a pyranometer, depends on the types of pyranometer. Thermopile technology is able to convert thermal energy into electrical energy based on temperature difference. Thermopile pyranometers measures the flux density of solar radiation from a 180-degree angle of view. The temperature of the sun exposed area and shadow area are used to determine solar irradiance. Photodiode-based pyranometers are equipped with a photodiode that is capable of converting the solar spectrum frequency into high-speed current. As the temperature rises, the current produced also rises. Photodiode-based pyranometers are equipped with a photodiode, optical filters or diffuser, and a housing dome. The photodiode is the sensor and the current it produces is in proportion to the radiance. A photovoltaic pyranometer uses its photovoltaic cell to measure the radiance of sunlight. Guys, do you know how does a pyranometer measure its irradiance? It's actually the temperature difference between the active and passive junction generates a small electrical voltage to provide the solar irradiance measurement. Photovoltaic. Photovoltaic is the direct conversion of light into electricity at the atomic level. Some material has a property known as the photoelectric effect that causes them to absorb photons of light and release electrons. When these free electrons are captured, an electric current results that can be used as electricity. The photoelectric effect was first noted by a French physicist, Edmond Becquerel, in 1839, who found that certain materials would produce small amounts of electric current when exposed to light. In 1905, Albert Einstein described the nature of light and the photoelectric effect on which photovoltaic technology is based, for which he later won a Nobel Prize in Physics. The first photovoltaic module was built by Bell Laboratories in 1954. It was built as a solar battery and was mostly just a curiosity as it was too expensive to gain widespread use. In the 1960s, the space industry began to make the first serious use of the technology to provide power aboard spacecraft. Through the space program, the technology advanced. its reliability was established and the cost began to decline. During the energy crisis in the 1970s, photovoltaic technology gained recognition as a source of power for non-space applications. Let's look for energy generation of photovoltaic cell. Do you guys know how photovoltaic cell can generate energy? Let's look. Energy from the sun is the most abundant and renewable energy on earth. In order to utilize this energy to transform to electrical energy, we need help from sand. Yet, isn't it? Yes, it's true, sand. The sand has to be converted to 99.99% pure silicon crystal to use in solar cell. To obtain that, the sand has to go through a complex purification process, which is sand mixed up with carbon until 2000 degrees Celsius and is produced pure raw silicon 98%. The raw silicon gets converted into a gaseous silicon compound form. The mixed with hydrogen to get highly purified polycrystalline silicon. These silicon ingots are reshaped and converted into very thin slices called silicon wafers. The silicon wafer is the heart of structure of the silicon atoms are bonded. Bonded means no freedom. Similarly, the electron structure also has no freedom of movement. Assume that phosphorus atoms with 5 valence electrons are injected into it, one electron free to move. When the electron gets sufficient energy, they will move freely as shown in the video above. When light strikes the electron will gain photon energy and will be free to move. To make the electron flow unidirectional, a directional force is needed, which is p-n junction. Due to the no p-n junction, the electron cannot move in unidirectional. There will be no flow of current. Similarly, to the n-type, if you inject boron with 3 valence electrons into pure silicon, there will be one hole for each atom. This is called p-type doping. If joined, some electrons from the n side will migrate to the p region. There will be a depletion region formed. Due to the electron migration, the n-type boundary become positive charge and p-type become negative charge. There will be electrical field formed. In this way, solar cell gives continuous direct current. The video shows when the light is interpreted to the p-n junction, the photon will energize the electron to move out from its orbits. The escaped electron will find a hole for a placement. From there is p-n junction formed. So this is a unidirectional current flow and it makes electrical current flow. And the video shows about the direct current by the panel. If light striking the electron hole, the pairs are generated in a wider area compared to the previous case and make the depletion area wider and result more current generation. And the video shows the more current flow through the circuit. Due to the light striking the electron hole pairs in a wider area. A photovoltaic cell has different layers. negative side is connected to the back side of the lead cell through copper strip and it forms series connection and parallel to another cell similarly and form a solar panel. Combination of series and parallel connection of the cell increases the current and voltage values to usable range. EVA sheet is to protect them from shocks, vibrations, humidity. This diagram shows arrangement of solar cell to make a PV system. Combination of solar cell makes solar module. Combination of solar module makes solar panel. In a PV system, the arrangements are arranged in a solar array form. There will be electricity meter, AC isolator until tracking. The intensity of solar power at a point of observation is known as solar irradiance. The intensity of solar energy at a point of observation known as solar irradiation, and the intensity of solar power on top of the Earth's atmosphere is known as solar constant. And the slides finish. Thank you guys for your cooperation.